All right, we are continuing with parallel and perpendicular lines, but in this video, I'm going to remind you the different forms of the linear equations and then how to write equations of lines that are parallel and perpendicular. Okay, so the first type of equation for linear functions is the slope-intercept form. That's the y equals mx plus b. Don't forget that m is the slope and b is the y-intercept. All right, so for example, if I was going to write the equation here, this is the y-intercept, so b would be equal to 3. And my slope, I'm going to get by counting the slope, 1, 2, 3, 4 over 1, 2. So slope is negative 4 over 2, which reduces to negative 2. That means my equation is going to look like this, y equals negative 2x plus 3. Hopefully that looks familiar to you and it's easy peasy. So try this one on your own. Pause the video. So you should have gotten y equals 3x minus 5. All right, the point slope form of the equation looks like this. Y minus y1 equals m times x minus x1. I don't know if you learned this format or some people learned a format that looks like this with h and k. Either way, this is being added over. Okay, so it looks like this. Okay, so it's the same thing, it's just this one has the y1 moved over to the other side. Okay, either way, we use this obviously when we have a point and a slope. So to remind you here, I would do, this is my x1, this is my y1, this is my slope, my m. So if I was doing point slope, I would do y minus 5 equals 2 parentheses x minus 3. Or in the HK version, it would just look like this. Y equals 2 parentheses x minus 3 plus 5. So you see it looks exactly the same as this green one, but all I did was add the 5 over to the other side. Okay, either way is fine. So now how do we use that in a parallel line situation? Well, if I wanted to write an equation of a line that goes through this point, but it has to be parallel to this line. So in order to write an equation of a line that is parallel, we know that the slopes has to be the same. All right, so the slope of this original equation that they gave us is 2. So the slope of our line, of the parallel line, has to also be 2. So we have the point and we have the slope. So we can just do, I'm going to use the HK, so y equals 2 parentheses x minus 1, and then I have a minus 1. All right, so that would be an answer. You could also put it in point slope form. That would be y plus 1 equals 2 parentheses x minus 1. That's totally fine. I'm sure in algebra you were trained to distribute and get it into slope-intercept form. That is fine too. Okay, unless it says in the directions what form it needs to be in, I will accept all forms. All right, so in this one, we're going to write an equation that goes to that point and is parallel. I want you to try this one, so pause the video and then check yourself. So I have all 3 forms of the same answer boxed in there, so if you have one of those, you are doing it correctly. If you didn't get one of those answers, make sure to ask about that in class. All right, so now that we've done parallel, let's talk about perpendicular. So perpendicular, remember, our slope has to be opposite reciprocal. So here, if I have a slope of negative 3, then the perpendicular slope has to be positive 1 over 3. So my equation, remember using this point, so I have y equals 1/3 x minus h plus k, or in point slope form, that would look like this, y minus 2 equals 1/3 x minus 3. Okay, so try this one on your own, pause the video, and then check your answer. So again, here are the 3 forms. Make sure you have at least one of those for your final answer, and if not, ask about it in class. Okay, so standard form, remember, looks like ax plus by equals c. So you see the x and the y are on the same side where you have a constant on the other. Okay, and a and b are not both 0. All right, so that's what standard form is. Then we also have those horizontal and vertical lines. Remember, if I am graphing y equals 3, that is a horizontal line. It means it's going to be crossing the y-axis at 3. So 1, 2, 3. That is what that would look like. Okay, and if I see an equation like x equals 3, this one is a vertical line. It is crossing the x-axis at positive 3. 1, 2, 3. Okay. So you see, we said all horizontal and vertical lines are always perpendicular. Okay, so these would be perpendicular lines. This one is our standard form, where we have x and y on the same side and a constant on the other. So if we were graphing this as a reminder, it's pretty easy just to find the x and y intercept. So if I find the x-intercept, remember if I'm crossing the x-axis, it's going to look like something comma 0. And then if I'm crossing the y-intercept, or the y-axis, which is the y-intercept, it's going to look like 0 comma something. So remember, we plug in zeros to help us find each part. So if I want to find the x-intercept, here, let me write this down. The x-intercept, I'm going to be plugging 0 in for the y. So that's going to be 2x plus 3 times 0. So you might have also heard cover-up method. All right, so that's the same thing. So that we have an x-intercept of 3, 0. Okay, for the y-intercept, I'm plugging in 0 in for x. So that's 2 times 0 plus 3y. So that's 0. So that means that I have 3y equals 6. So y is equal to 2. So that means I have the point 0 comma 2. And then once you have 2 points, remember you can always draw a line through 2 points. Okay, so just as a reminder, in case you ever have to do that and then find slope and things like that, you could also rearrange your equation to be in slope-intercept form. So for example, if I take my original 2x plus 3y equals 6, I could try to get the y by itself. So I could subtract the 2x and then divide by 3. Make sure when you divide by 3, you divide everywhere. And that would give us y equals negative 2/3 x plus 2. And then I can double check my graph. It should have a y-intercept of 2 and a slope of negative 2/3. So yeah, y-intercept of 2 and then down 2 over 3. Okay, so quick review of all those different kinds of equations and then how to use them to write equations that are parallel and perpendicular.